All right, good morning, everybody. Hopefully, you're doing okay this morning. So, today we're going to continue to talk about Chapter 2, Section 4, and we're going to continue to solve these multi-step equations. I know you used the word multi twice, and that's kind of redundant, but there's a lot going on in these equations. There's distributive property, then you got to move the variables onto one side, and there's a whole bunch of stuff going on. So, these are definitely challenging problems. So we're going to continue to talk about those. I'm going to show you 4 more examples, and hopefully that will help you and further your understanding of how to solve these multi-step equations. So let's get started. We're going to start with this letter E, and letter E has only variables on one side, which is nice, but there is some work to do on one of them. So if you look over here, there's only an 84. There's nothing else to do. And as I said in a previous video, you always want to check each side individually first to make sure that there's nothing for you to do before you try to start moving variables around. Now, on the left-hand side, there is a -7 that needs to be distributed to both of those. So that's what we're going to go ahead and do, and we're going to distribute that -7. -7 times -4p becomes 28p. And then -7 times +8 is -56. So you can see I distributed that -7 to both terms inside the parentheses first. The next thing that you always want to look to see is, are there multiple variables that need to be combined? In this case, there are not. There's only one 28p. So now we can just proceed to solve for that 28p. And the way that we're going to solve for that is we're going to add 56 to both sides. And you can see that the 56 cancel. I'm left with 28p equals, and 56 plus 84 ends up being 140. Now from there, I'm going to divide both sides by 28 because the 28 is multiplying p, and we need to undo that. So this cancels, and we're left with p equals, and I am not positive if 28 divides into 140 equally, but let's find out. And the answer is it does, and it turns out to be 5. So there's your solution to the first equation. Now, moving on to the next one. This is similar to the last one, but there's a little bit extra work in this one, and you'll see why here in a second. So I'm going to draw my line down from the equals. I do prefer that you do that to keep things organized. You can see on the left-hand side, there's only a 105. There's nothing to simplify or distribute or combine or anything over there, so we're good. We can leave the 105, but looking at the right-hand side, this 3 needs to distribute. So you need to distribute that 3 first. And so we're going to have 105 equals 3 times 5 becomes 15. 3 times 3x becomes 9x. And then we have the 6x that just drops straight down like that. So you're always working with the left-hand side and the right-hand side separately until we have them completely condensed as far as they can go. And if you look at the right, there's a 9x and a 6x right there. That 9x and 6x need to be combined first. So you're always looking to clean the sides up on their own. So the 9x and the 6x become 15x, like that. Now, if you look at the right-hand side, 15 and 15x, those are not like terms. We can't combine them anymore. So now we can go ahead and proceed to solve for x. Everything's simplified on the left. Everything is simplified on the right. And the way that we're going to do that, as always with these two-step equations, we always add or subtract first. So I'm subtracting 15 from both sides, which cancels that 15. We still have our 15x right here. 105 minus 15 is 90. And then this 15 is multiplying the x. So I'm going to divide this by 15, divide this by 15, and I'm going to be left with x equals 6. And there's our final answer. X is 6. All right, so I have two more to show you. These are special solutions. Okay, so there can be other kind of funky stuff that happens when you try to solve these. So I'm going to show you a couple examples of that. So once again, I'm drawing my line where the equal sign is first. I want to look at the left-hand side. Is there anything over there to simplify? The 7 minus 3r. And that answer is no. There's no like terms, so we're good over there. But looking at the right-hand side, you can see that there's this minus 4, this negative 4. It needs to distribute to the 2 and the r. So we're going to go ahead and do that. So I'm going to leave the 7 minus 3r on this side. And then the r is still going to come down. This r is still going to come straight down like that. But then the negative 4 multiplies 2, and you get negative 8. And then the negative 4 multiplies the r, and I get negative 4r, like that. So I distributed. Remember, the sign has to go with the number after it. So not only does the 4 get distributed, the negative also gets distributed. So it's negative 4 times 2 is negative 8. Negative 4 times r is negative 4r. Now we do want to double check each side, make sure there's nothing to simplify or combine. In this case, there is. We still have a 1r. And we have a negative 4r right there. So 1r and then minus 4r, those two need to combine. And 1 minus 4 is negative 3. So we're going to leave everything on the left the same. And then this 1r minus 4r becomes negative 3r. And then the minus 8 just drops down. Okay, so we combined our like terms. So now if you look at the left-hand side, that's as simplified as it can get. And then if you look at the right-hand side, that is also as simplified as it can get. So once we've simplified the left and the right-hand side, now we can proceed to move all the variables over. All right, so it really doesn't matter in this case which one we're going to do. So I think I'm going to add 3r here, and I'm going to add 3r here. Now, when I do that, something weird happens, okay? What ends up happening is this 3r goes away, but this 3r also goes away. So we're not left with any variables left. We just have a 7 over on this side, and we have a negative 8 over on this side. And so if you look at this expression says 7 equals negative 8. That's false. That's definitely not true. So we want to put a line through there and say those are not equal. And if you get this to happen, meaning all the variables go away and you're left with a false math statement that is untrue, you can say false, and then you can say no solution. So what that means is there is not a number in the universe that would ever make this equal to this. It's not possible. Can't do it. And we know that it's not possible because you ended up with a false statement when you tried to solve this. All the variables went away. Now the last one I'm going to show you is this one. I'm going to draw my line again in equals. I'm going to look at the left-hand side. There's nothing to simplify, so that's good. On the right-hand side, we need to distribute that 5 like that. So, we're left with 5t minus 7. And then we need to distribute the 5. So we're going to have 5 times t, which is 5t, 5 times negative 2, which is negative 10. And then we still have the plus 3. It just drops down like that. It does not get multiplied by the 5 because it's not inside the parentheses. So still looking at my expression on the left-hand side, the 5 and the t, these two right there, or excuse me, the 5t and then the 7, those aren't like terms, so we can't do anything with those. But looking over here, we have a couple of like terms that can be simplified. So we need to get those together first. So we have 5t minus 7 here. And over here, we're going to have 5t. And negative 10 plus 3 is negative 7. So now that we have combined the like terms on the right-hand side, we now have an expression where this is as simplified as it can be, and this is as simplified as it can be. So now we can proceed to get the variables all to one side. So I'm going to subtract 5t here. I'm going to subtract 5t here. When I do that, the 5t goes away. 5 minus 5, 0. Over here, 5 minus 5, 0. Uh-oh, everything canceled out again. But what I want you to notice is we still have this minus 7 that's going to drop. And over here, we still have this minus 7. So we get an expression now. Once again, we get a statement that says negative 7 equals negative 7. So if you notice, all the variables went away. All right, so this is another special case scenario. Over here, when that happened, we got a false statement, so it means there's no solution. But over here, we ended up with a true statement, right? Negative 7 definitely equals negative 7. This is true. So when you end up with a statement that just says negative 7 equals negative 7, or you get like 5 equals 5, anything that is true, that tells you that it's going to be an infinite number of solutions, which means there's infinity. They all work. Any number for t would make this original equation up here true. All right, guys. Hopefully that made sense. If you need anything, feel free to reach out in my email. Have a great day.